Okay, I want to have a look at some situations involving two circles now. Quite often the last part of an examination question will involve two circles. When you've got two circles, lots of different scenarios can exist. You could have case A, for example, where you might have something called concentric circles. Concentric circles are basically one circle contained within another circle, but importantly, they have both got the same centre point. In other words, they've got the same centre point but different radii. They are known as concentric circles. If in a question you are asked to prove two circles and you know their equations, if you're asked to prove that they are concentric circles, all you've got to do is show that they have both got the same centre point and have different radii, and then they will give a picture similar to that, and that's concentric circles. A situation B could be something like this, where you've got one circle contained within another, but they don't have the same centre point. That's a situation that could exist. But I've got to be honest with you, I have rarely, if ever, seen a question involving that type of question, that type of situation. Type C is a situation whereby we have got one circle contained within the other, but this time the circle touches at one point there. Okay, that is a situation where we've got one internal intersection point between the two circles. Okay, that's situation C. If I look at the situation here, if you consider the distance apart of the two centres of those circles, call that distance D. Okay, and if you consider from there to there, I hope you can see this, is R1, the radius of the big circle, and that distance from there to there is R2, which is the radius of the small circle. So we've got R1, we've got R2, and we've got the distance D. Okay, so if you take away the two radii, in other words, you take the big radius, which is R1, and you subtract R2, what you'll be left with is the distance between the two centre points of the circles, like so. So D is equal to R1 minus R2. So what I'm saying to you is, in a question, if the exam question says you've got two circles, prove that they intersect at one point only, internally, what you've got to do is work out R1 and work out R2 of the two radii, subtract them to get an answer. Then you've got to take the two centre points, work out from coordinate geometry the distance between those two centre points, so you work out D separately, and if you find that the D value is equal to R1 take away R2, then you have that situation, and you have the two circles intersecting at one point internally, like that. Okay, so that's the test of intersecting circles at one point internally. R1 minus R2 must be the same as the distance D between the two centre points. Okay, situation D is, if you like, you can see that the progression what's going on. I've got that inside the circle centrally, still inside the circle but shifted over, still inside the circle, shifted over, so it's now touching, and now the smaller circle, as I've drawn it, is now moving outwards, so you get the two circles overlapping, so the circles intersect at two distinct intersection points there and there. Okay, now one way of working out those two intersection points, if you were asked prove that two circles intersect at two different points, would be to take the equation of the first circle, take the equation of the second circle, and solve them simultaneously. Sometimes that's okay, sometimes you can do it that way. However, it is sometimes quite awkward, because quite often you've got two quadratic equations there. Both of them are circle equations, they're both quadratic, it's not one linear, one quadratic, and sometimes that can cause you a headache. So if you were ever asked to work out or prove that two circles intersect at two specific points, like so, then I wouldn't try solving the two equations simultaneously. What I'd be tempted to do is something like this. You've got the radius of the first circle, R1. you've got the radius of the second circle R2, like so, and you've got the distance apart, which we'll call D, of the two centre points. And I would suggest that if you were to add up R1 plus R2, like so, okay, you'll always find that the distance apart between those two centre points, the D value, is going to be less than the R1 and R2 added together. Okay, as you can see, because the two circles are overlapping, the R1 and the R2 overlap, okay, and to give us the D value. So D is always going to be less than R1 plus R2 added together. So there is a very simple test to see if two circles intersect at two distinct points. Work out the radius of the first one, work out the radius of the second one, add them together, then work out the distance apart of their two centres, and if the distance apart is less than the radii R1 add R2 put together, then you've proven that you've got the intersection and you've got two distinct points of intersection. Okay, so there are the first A, B, C, the first four situations for intersecting or two circle situations. We've got another couple of situations you could have, so if I now just make some more space, you could have this situation whereby we'll call this situation E, whereby you have the larger circle again. You don't have to have one being smaller than the other, but I'm just demonstrating this. The last one I did had them intersecting like so. I'm going to carry on moving it to the right, so now the smaller circle's moved a bit further right and it is still intersecting, but this time it's only intersecting at one point, and that point is external to both circles. So we've got an external intersection point, and it's just one external intersection point. If I put in the centres like so of the two circles, that centre gives a radius R1 and this one has a radius R2, and then the distance apart of the two centres I'll call D, like so. I think that's a very easy picture to see, that if you add R1 plus R2 together, then you get the distance between the two centre points. So work out the distance between the two centre points, work out R1, work out R2. If you find that the distance between the two centre points is the same as the radius of the first circle added to the radius of the second circle, you will find that you have that setup, which means, in other words, that the circles are touching externally at just one point, like so, and that's the picture. Okay, now that's the theory of it. Obviously, if you relate to some of the exercises we do later, you'll see this sort of thing in action. Okay, so that's the basic theory of it. Okay, and then if I take situation F, let's say I take the bigger circle again, and this time I'm going to take the smaller circle and shift it a little bit further along. So this time the small circle now is outside the big circle. You've got the radius of the big circle, R1, you've got the radius of the small circle, R2, and you've got the distance apart, D, of the two centre points. And I think just by looking at the picture, it is abundantly clear that in this case, the distance apart of the two centre points is no longer going to be equal to R1 plus R2 as it was there. This time, let me get it right, the distance must be bigger than R1 plus R2. So if you want to show that two circles do not intersect and they are external to each other, like that, you work out the radius of the first, you work out the radius of the second, you add them together, then you work out the distance apart of the two centre points, and you show that the distance apart must be bigger than the two radii added together. Okay? And then that will prove that situation. So in many circle questions that you get in the exam, part A might be a basic work out the equation of a circle, or find the centre, or find the radii of a circle. Part B might start talking about using simultaneous equations with a straight line, for example. And then part C might include a question on two circles, covering one of the situations that we're just talking about here. Now all of these are obviously theoretical. You should be making notes about them, so they're in your notes. In the next video I'll do some calculations to show some of these things in action, to show you how they work, because if you try and learn it like this, a lot of people find that very difficult and they get very confusing. So if you actually do some applications, it shows how easy they are. Okay, but that's for the next video.